right, so we are moving on to parabolas. So hopefully the rest of this section is going to be relatively simple. You should have already seen most of this stuff in college algebra, but here's just a quick reminder. So parabolas are a set of points that are equidistant from a fixed point. We call this fixed point the focus, and a fixed line, which is called the directress. All right? So if we have something like this, well, I guess it'll be something like this, right? So we have a focus point in the middle, and we have a line on the end. So the way that this actually works is the distance from any point from this line, or from this point to this line, right, should be equidistant. So it is the same length. If I was drawing it correctly, you would see that that's actually how this works. Any point on the parabola, right, going from the focus to the point and from the line to the point should all be the same length. Good. So we have two different ways to draw this. We have a vertical parabola and a horizontal parabola. So we're not going to talk about any other types, so just the horizontal and the vertical. So a horizontal parabola, obviously, it's either going to go up or it's going to go down. So for a vertical one, right? So the equation for this is going to be x minus h squared equals 4a times y minus k. So if it opens up or opens down, we can see that's how it's going to go. If it opens up, it's because a, this number in front of the y minus k, is positive. It opens down if that a is negative. Right? So you can kind of think positive people smile, so that's why it goes up. Negative people frown, so that's why it goes down. Likewise, if we have the horizontal parabola, right, so it's either going to go to the left or it's going to open to the right. So it either opens left or right. And the equation in this case, basically the x and the y's just switch. So for the horizontal, we get y minus k squared equals 4a times x minus h. It's going to open to the right when a is positive, right? Because if you talk about an x-axis, right, going left to right, the right side is the positive side, the left side is the negative side. So when it opens right, it's because a is positive. When it opens to the left, it's because a is negative. So we are going, you should be given these formulas, but I'm not going to tell you which one's which, right? So how can we determine that these are parabolas and that this is the vertical parabola and this is the horizontal parabola? So here's some tricks of the trade. So they are parabolas when one variable is squared. So we've already seen circles had both of them being squared. In the future, we will also have both of them being squared, so you can tell that it's the parabolas because only one variable is being squared. Now, when it's determining whether it's the vertical or the horizontal, right? So the vertical goes up and down. If we notice, is this a function? Does this pass the vertical line test? Yes, it does, right? So it is a function because the graph passes the vertical line test. And if we notice looking at the graph, right, if x is being squared, then that's going to be a function. Now let's look at the horizontal one. Are the left and right ones functions? No, right? They don't pass the vertical line test. And if you notice, when y is being squared, that's also doesn't pass. It's also not a function, right? It's not going to pass that test for a function. So that might be a good way to remember. So the x squared, that's a function, so that's going to go up and down. The y squared, that's not a function, so that's left and right. But either way, right, no matter which way you have it, our vertex, so the smallest or biggest number, right, or biggest point, or the one to the most left or most right, depending on which one you have, that vertex is what we call it. and that vertex is going to be h comma k. So if you can get it into our form, right, if you can get it into the form that we got, it's just going to be h comma k, no matter which one you are using. Now the focus, so if you go from the vertex, you need to go inside A units. Right? If you go inside A units, that's where the focus, excuse me, is going to be. So knowing which direction you're going is going to be very helpful when trying to find the focus. And likewise, right, since everything has to be equidistant, the directress is going to be found by going outside A units. So we go inside A to get F, the focus, and we go outside A to get the directress. Good. There's actual formulas. You can look those up in the e-text or the textbook if you want. If that's what you want to memorize, that's fine. But I think this is how I do it, thinking about these in the most generic way possible, so that way we can figure it out. And I think just having less formulas to memorize is probably going to be better than more formulas to memorize. All right, let's talk about graphing, and then we'll actually get into some problems. So the way that we graph it, first we convert the equation into our format, potentially by completing the square. So if needed, we'll need to complete the square. Then we determine our vertex. So how about, here's a lot of words. Let's actually look at an example. Let's go through this step by step as we're looking at an example. So let's find the focus and directress of the parabola y equals negative 1/6 x squared. So we can see that x is being squared, so our formula should look something like this, right? So let's make sure that the x squared is on one side. So let's flip the sides. Equals y. And now if we notice, there's nothing in front of the x squared. So let's get rid of this fraction. And of course we can do that by multiplying by negative 6/1 to both sides, right? So we end up with x squared equals negative 6y. All right, so that was step one, convert it into our equation. Maybe we need to do completing the square, but this time we didn't need to. Step two, find the vertex. All right, so the vertex is going to be basically, what number are we subtracting from x in this example? Well, nothing, so we're subtracting 0. All right, what number are we subtracting from y? Again, nothing, so our vertex is just going to be 0, 0. All right, step three, determine which direction the parabola is opening. So is it up and left or right, up and down, or right or left? So since x is being squared, we see it's going up or down, right? And since y is negative, we know we're going down. All right. Step four, let's solve for a. Remembering that the equation has an 4a in front of the linear variable, right? So the first degree variable. So our formula is 4a times y minus k. So in this case, 4a should be negative 6, right? So we have negative 6 equals 4a, and this is how we'll solve for a. So a is just going to be negative 3/2. All right. Step 5. So to find the focus, remember we said we want to go inside the parabola a units from the vertex. And that's how we find our focus. And then of course we go outside a units to find the directress. So remember that the focus is a point, the directress is a line. So the directress is going to need to be given in line format. All right, so if we graph it, which graphing it is going to be the way to find all this stuff anyway. So we're at 0, 0. We know we're going down, so to go inside, we need to go down negative, or we need to go down 3/2, right? So negative 3/2 is going to be right there. So what point did we end up at? So this is our focus, which means that the focus is going to have to be at 0, negative 3/2. Which I think is just so much easier than having to memorize some formula to figure it out. Then the directress, we just go up 3/2, right? So that's going to be right there. So what is the directress? Remember, it's an equation of a line. So it's not just 3/2, it's y equals 3/2, right? If you tell y equals 3/2, that's telling me it's a horizontal line. So if you just write the directress is 3/2, that is incorrect. It is not a number, right? It's a line. And so the equation of a line needs to have that y equals. That's really important. Good. All right. And then we know it's just going to go down like that. So just a quick sketch, something like this, that's all I need. I don't need anything more complicated than that. And that's it. All right, let's do another one. So example number 2. So sketch the graph, find the focus, directress, and vertex. So here's one where we definitely are going to need to complete the square, right? So y is being squared. So let's put all the y's on one side. And we'll put the rest on the other side. So if you notice, I just switched the signs and moved the 22 to the other side. So since y is being squared, right, this is going to be our equation. So let's complete the square. So remember, completing the square is going to be b over 2 squared. So in this case, b is 8. So 8/2 is 4, and 4 squared is 16. We want to make sure that we add 16 to both sides. So we get y squared plus 8y plus 16. And that equals 2x minus 22 plus 16. There we go. Nice. All right. So factoring off one side, we see that this is just going to be y plus 4, right? That's where we get that. If we factored this out, we get y plus 4. On the other side, we get 2x minus 6. So this is almost in the form, right? The only thing is that we're supposed to have nothing in front of the x, right? We need to factor out anything that's not that's in front of the x. So to factor it out, we get 2 times x minus 3. So this is the form that we need to find. Good. So let's give ourselves a little bit more space. So this is our equation. We see that the vertex is going to be, well, we're subtracting 3, right? And we're subtracting negative 4. So basically, it's what makes this equal, what makes it equal 0, right? So we can plug in 3, we can plug in negative 4. So our vertex is 3, negative 4. All right. Next is gonna, which way does it open? So we can see that it's going to open left and right because y is being squared. Since the number is positive, it's going to be opening to the right. All right. Next, we need to figure out what is a. So remember, the number in front of the linear term is going to be equal to 4a. So a is 1/2. So let's graph it. So we go 3 down 4. All right, so that's our vertex. We said we are going right. So we need to go right 1/2. Right, so if we go to the right 1/2, what point did we just end up at? So that was 3, and you added a half, so 3.5 -4 is our focus, right? What's our directress? If we go the other direction, we see that this is going to be 2.5. But hopefully you remember that 2.5 can't be the answer because that's just a number, and the directress is a line. So it's a vertical line, so it needs to be x equals 2.5. And then to graph it, you just make a parabola to the right. And that's it. That's all I need. All right. So let's do the opposite. So find the equation that has a vertex at the origin, opens to the right, and passes through the point 7, -3, and then sketch the graph. So if the vertex is at the origin, we know h comma k equals 0, 0, right? It opens to the right, which means that y is being squared. So we're going to use our formula, y minus k squared equals 4a x minus h. We know x and k are both 0 because we're at the origin. So we get y squared equals 4ax. All right, so we know that it goes to the origin. We also know that at the point 1, 2, 3, 4, 5, 6, 7, go down 3 is on this graph. So if it opens to the right, this is what it's going to look like. So how can we figure out what the equation is? What's the only thing we need to know for this equation? We need to know the letter A, right? So what we got to do is plug in our point. So -3 squared equals 4a times 7. And then we just solve for a. So 9 is 28a, which means a is 9/28. So plug it back in. Our final equation is going to be y squared equals 4 times 9/28x. Which means, right, we can simplify that to get y squared equals 9/7 x. And that's our equation. All right, so now we just need to figure out part B, what is the focus and the directress of the parabola? Well, since we said that A was 9/28, right, we need to go into the parabola A. So we go into the parabola A. What point do we end up at? Right, the focus is just going to be 9/28, 0. If we go outside the parabola A, we should see that we're at x equals -9/28 for the directress. -9/28. And that's it. So again, you can memorize those formulas if you want, but I think it's easier just to remember those small ideas, or the general ideas for everything. It works for all of it. All right, example number 4. So a parabola has the vertex -4, 2, and the directress y equals 9. So write the expression in this form. So if the directress is y equals 5, and we have a vertex at -4, 2, so let's actually kind of graph that. So -4, 2. So we have that the directress at y equals 5. So this is where the directress is. So it can't go past that, which means what direction does our parabola have to go? So hopefully you see it has to go down. So since it's going down, right, we know that we have an x minus h squared equals 4a times y minus k. We already know what the vertex is, so we can just plug that in. So we get x minus 2 squared equals 4a times y plus 4. So now we just got to figure out what's a, and then we need to put it back into this form. So what do we get for a? Well, we know the vertex and we know the directress. And what do we know about the relationship between the vertex and the directress? How do you get the directress if you know what the vertex is? Well, if you remember, you go outside a units, right? So if we go outside a units, if we're at 2, right, how far away is our directress? We see it's 3 units. So a is 3. But remember, which direction is it going? It's going down. So a has to be -3, right? Because if you're finding the focus, you would be going down 3 to find the focus. Good. So plugging that in, x minus 2 squared equals -12. Y plus 4. So that's it. That's our standard form for our parabola. But they said to put it in this form. So let's just put it in that form. Yeah. So we get x squared minus 4x plus 4 equals -12y minus 48. So we can add 48 to both sides. So we get -12y equals x squared minus 4x plus 52. And then we just divide everything by -12. So y equals -1/12 plus 1/3 x minus, and then if we want to simplify that, we would end up with 13/3. Oh, yeah, don't forget the x squared. That's important. Good. All right. Now we just got 2 word problems and we're done. And for these, actually, these are going to be the easiest word problems you have ever done. It's going to be so great. So the interior of a satellite TV antenna is a dish having the shape of a finite paraboloid with a diameter, of 12 feet and is 6 feet deep. So that should just say deep, not deeps, probably. So find the distance from the center to the focus. So the focus is going to be the same as always, right? So essentially that's typically where like an antenna would be. It's going to be at the focus. So if you have a dish like this, right? The antenna is where we put our focus. So if you want to know real world scenario, here's the real world scenario for parabolas. That's where you get the best sound. All right, so since we get to determine what the parabola looks like, we can determine what it is. So let's just make it start at the vertex. Sorry, that didn't make any sense. Let's let the vertex start at the origin, right? Since we can put it anywhere on this graph, let's just make it the origin. And let's just make it go up. And we can do this for every single problem. So since it's going up, right, we know it's going to be x squared. And since it's at the vertex, it's just going to be x squared equals 4ay. So if you do it right, this can be your equation every single time you do a parabola application problem. So we know that the diameter of the dish is 12 feet, and we know the depth of the dish is 2 feet. So all we need to know is what A is, right? That's how we can figure out what the focus is. Well, what's one point on this graph? So for instance, what would this point on the graph be? So some of y'all might say it's 12.2, but that would be incorrect, right? So if you notice, the entire diameter is 12 feet, which means that the radius is 6 feet, right? So if we go over and up, we're going over 6 feet, up 2 feet. So the point on this graph is 6, 2. So if we plug that in, 6 squared equals 4a times 2. We get 36 is 8a. So a is 9 halves, which is about 4.5 feet. And by about, it's exactly 4.5 feet. Yeah, so since A is the focus, right, you're going into it, into the focus, into the parabola to find the focus, A. Right, so what's the distance from the center of the dish to the focus? It's just 4.5 feet. And that's it. We're done. Told you it was easy. All right, last problem. So a reflector is to be constructed with a focal length of 10 feet and the depth of 5 feet. So find the radius of the reflector. So again, we can just have our vertex at 0, 0, and we can be going up. So we're going to have x squared equals 4ay. So we say the depth is 5 feet. And we see that the focal length, so is 10 feet. So if we go all the way up here, right, we can say that's where the antenna is. So 5 feet. What letter is this 5 going to be representative of? You can see it's this y, right? Y is 5. What letter represents the 10? A, right? That's the focus. So we can just plug it all in. So x squared is 4 times 10 times 5, right? 4 times 10 is 40. 40 times 5 is 200. So x is going to be plus or minus 10 times the square root of 2, right? Because you can do square root of 200. 200 is 102, which is 10 and 10, right? So x is plus or minus 10 times the square root of 2. So here's the point, 10 square root of 2, 5. And here's the point, negative 10 square root of 2, 5. Oh. Yep, just messing up on me right at the end here. There we go. So we're trying to find what the radius is. The radius is just 10 square root of 2 feet. And that's the answer. So that would be about 14.1 feet would be the radius. What if I asked for instead the diameter? What would the diameter be? Obviously, it'd be 2 of them, right? 10 square root of 2 times 2. So 20 square root of 2, right? Which should be about 28.2 feet. Cool. All right, that's it. If you have any questions, like always, just let me know.